Hello, 8th graders, and welcome back to the math videos. There was a decent amount of people who very much wanted to have the math videos still because they said they're really helpful. So we will continue doing them unless for some reason people stop watching them again or whatever. But thank you for watching it. If you are watching it, you are hearing me because you are watching it, so good job. So we're going to postpone our quiz until after spring break because I really wanted to start systems of equations, which is what this lesson is all about, which pretty much is like multiple equations being solved at once, or multiple equations or lines interacting and having a solution together. So it's not just us working with one equation anymore. It's going to be us working with two equations for right now. Okay, so this first warm-up problem, and this is section 13 in your book. I don't know the page, but just look for lesson 13 in your Unit 4 workbook, and you will find this picture. The instructions say to use the lines to decide whether each statement is true or false. Be prepared to explain your reasoning. Okay, you don't need to do that. But what they are asking is what the solution is and if that makes sense. So it says a solution for number one, a solution to 8 equals negative x plus 10 is 2. So if they're talking about a solution and the only variable we're working with is x, right? And then I'm looking at something like this, 2 comma 8, x and y. The only thing that we can really consider is an x value. So just even without using the graph, if I were to just plug it in, I would say, okay, 8 equals negative, and then I plug my 2 in, plus 10. And then 10 plus negative 2, that's 8, right? 8 equals 8. So I could say that's true. So I could put a t next to it. But you could also use the graph, and you could see that both of the lines pass through here, right? They pass through 2 on the x, both of them. So you could have also done it that way. A solution to 2 equals 2x plus 4 is 8. So this is where I could go and plug in again. So I could say, or I could use the graph, and I could see that, 8 is in the y. And I could try to figure out if there was an 8 in the x. But if we're looking at a variable like this, where it's x, you don't want to be looking at y to plug in. That wouldn't make sense, right? Because we're working with x. So they're not very good at explaining it in this book. They're assuming you remember a lot of things from last year, which I know I even forget a lot of things. So I don't expect you guys to remember. We're just going to try to figure it out the best we can. So for this one, I'm just going to go ahead and plug 8 in. So like 2 equals 2 times 8 plus 4. You could keep going, or you could just look at that and common sense say, there's no way that 2 times 8 plus 4 equals 2. That doesn't make sense. So I'm just going to say false. If you really want to go ahead and solve the whole thing, have fun. You can totally do that, but you don't need to. Okay, number 3. A solution to negative x plus 10 equals 2x plus 4 is 8. So what they're saying here is that this 8 would be plugged into this x, and somehow they would equal each other. So if you're the kind of person who likes to go and plug numbers in, you could go for it. So you could be like, okay, negative times 8 plus 10 equals 2 times 8 plus 4. But already I look at that and I say, oh, well, that's 2, and that's a big number. It's 20, if you want to know. But 2 does not equal 20. So that's one way that I could say that this is false. Another way that I could say that this is false is by looking at the two equations and where they cross. And where they cross, there is an 8 there, but it's not in the x. It's in the y. So that is why it is not true. If we were talking about having a y in there, and we were talking about the y part of the coordinate pair, then that would be. but you can always plug it in, and if you plug the numbers in and it's not equaling to each other, that's the best way to check. So if you get confused with the graph, I would just do that. I usually like to do equations instead of the graph, but whatever makes more sense. Number 4 says the solution to negative x plus 10 equals 2x plus 4 is 2. So I'm going to let you guys do this one on your own. But what you can do is you can look and see, do these two equations cross where x equals 2? This is where they cross, right? Where I just drew the blue dot. Or you can plug 2 in and you can literally go like negative, okay, put the 2 plus 10 equals 2 times 2 plus 4. And if those equal to each other, then it's true. And if they don't, then it's false. Okay, number 5 says there are no values of x and y that make y equals negative x plus 10 and y equals 2x plus 4 true at the same time. So you guys can do this one on your own as well, but what this one is saying is true at the same time means they intersect. So I'm going to let you guys decide that for yourself. Do those two lines intersect? I think that you can figure that out, right? I think so. All right. We're going to do this part of this next one, and then you'll do part on your own. And then in your book, lesson 3, I can't figure out a way for us to do this without making more work for me and for you guys, because it was meant to be done in partners and with extra worksheets and stuff. So we're just going to cross it out, because it's just going to be too much work for all of us. So we're not going to do lesson 3. We're just, whatever, problem 3. We're just going to do problem 2. Okay, so here are systems of equations graphed on a coordinate plane. So systems of equations just means you have, like over here for A, you have 2 equations and they are interacting with each other in the sense that they cross at some point and they share a solution for that point in time. That is their solution. They cross somewhere. So what they want you to do for number 1 is they want you to match each picture A, B, and C with each set of equations. So like this first one, well, let's just look at it overall first so we don't like waste time counting slope. If you want to go and figure out the slope, you can, but it's going to take a while because these aren't going by 1s, they're going by 5s. So you'd have to go and find a point. So you could say, okay, this line crosses at 10, 0. Okay, 10, 0. Oops, this is being really difficult. 10, 0. And then I could find another point on that line where they cross, which is like, I don't know, 14 and 5. 14 and 4, something like that. 14, or oops, other way, 4, 14, somewhere like that. Then you could plug it in and you could go, okay, I'm going to do y2 minus y1 over x2 minus x1 and plug your points in, but that's a lot of work. So if I look at this, I can see that they all have a positive slope except this one that's in pink is negative. So all I need to do to get that one is figure out, well, which line has a negative slope. So remember if they go up to the right, so if the lines go like this, it's positive slope. If they go down to the left, it's a negative slope. If they go down to the right, it's a negative slope. You get the idea. Hopefully we did this a long time ago. So if I look at A, one of them goes up to the right, right? This goes up to the right. They all are going up and to the right. This is going up to the right. This is going up to the right. But this line that I drew a green star on does not go up to the right in any way. It is going down to the right. Or you could say up to the left. So that means that as it goes and goes and goes, it's getting more and more negative as it goes that direction. That's why it's negative. So I know right away that this is A, graph A. Then when I look at B, I can look for a fast way to do this too is to look for the y-intercept, because remember it's y, wait, I'm not going to write there because that's going to be confusing. It's y equals mx plus b, and that's your y-intercept, and that's your slope. I don't know why I didn't think of this until just now. This is an even faster way to do it than doing the slope. So I could look and say, this is my y-intercept. Why is it drawing weird straight lines? Oh my goodness. Although that's cool, that's not what I want. Okay, -10, -1. Those are my y-intercepts. So then I just like look at the graphs and I look for a line that crosses at those two y's. So where is there a line that crosses at -10 on the y? I see that graph C looks like it crosses right at -10. So there's that. So I can write C. And then process of elimination, I can assume that these two equations, although if you want to go and check it, it would work out, because this line, where if I erase this arrow, it crosses up here. That looks like it's about 27, right? And there's a 27. And the other one is a 12. And that looks like it crosses right at about 12. So I can safely say that's definitely B. I should have let you guys do one of those on your own, but that's okay. Okay, so the last thing that they want you to do is find the solution to each system and check that your solution is reasonable. So the solution to each system, that is where, what's happening? Where the lines cross. Don't think too much about like why or how or if things are different. We'll get into that later. For now, just know that where the lines cross, that's the solution to that system, because where they cross is where they are at that point in time equal. And that means that's their answer. That's like what they both share. So all you have to do is just record the coordinates of A, B, and C for where they cross. So like, you guys are all going to get slightly different answers because it's kind of impossible, I think, to read this tiny graph, which has no grid on it, because this book is kind of dumb, but it is what it is. So you just can kind of guess. So like this, let's look at A. If I'm looking, I think it's, I don't know, like a little bit less than 5 if I were to draw a line. That looks like 4-ish. And then if I were to draw, let me erase this. If I were to draw another line straight this way, oh, that's too high. It's above. This is really hard. You could probably have better luck doing this in your book than on computer. Oh my goodness, this is so confusing. It doesn't want me to, it's making me draw a straight line. Anyways, if you were to draw a line out from here, where I drew that orange, I think it crosses right below, so I think that's like 14. So what we said earlier, 4, 14, or maybe let's even say 3, because I don't know. Why not? That would be your answer, because that's where those two cross. And I'm actually going to double check what the book says. Yeah, 314. So if you get somewhere like near that, that's fine. So you'd write 314, and then what they want you to do for the second part is check your solution is correct. That just means plug those numbers in, so x and y, plug that into your set of equations. So you could just be like, okay, so for y equals 3x plus 5, I put in like that 3 and that 14. So then I say 14 is here, right? Because y. And then x is 3. So 3, oh my goodness. 3 times 3 plus 5, 14 equals 9 plus 5. And yeah, 14 equals 14. So you could say, okay, cool. I was right. Some of you might plug this in and you'll be like, oh, it's like 14 equals 13 or something. And then you can just go back and adjust it and make it whatever number makes it true, because that just means it was hard to read, if that kind of makes sense. So do the same thing for B and C and then skip that and you'll be done. And you do have to do your practice problems. So don't forget your practice problems. Practice problems. Which, that's supposed to be a C. Oops, it's really hard to write with this pen. All right, if you're confused, ask me questions.